Hi, hello and welcome to Mathway. In this video, you are going to learn about quadratic equation. In the previous videos, we have discussed about polynomials. If you haven't watched that videos, I am providing that link in the description box. You can go through it. So let us see what are the quadratic equations. So let us see the overview of this chapter. So this is the 5th chapter in the 10th class. So the topics, the concept to learn in this chapter are quadratic equation. So about the quadratic equation, what are the definition of quadratic equation and roots of the quadratic equation. So what are the roots of the equation, how to find the roots of this quadratic equations, and solution by factorization. Solution means finding the roots by the factorization method. It is the splitting the middle term method, and solution by completing the square method. So it is also one more method to find the roots for the quadratic equation. So for this academic year, so 20 to 21, this method is reduced. So there is no question is going to ask from this method, completing the square method. The next, quadratic formula. So very important, quadratic formula. So by using the quadratic formula also we can find the roots of the quadratic equation, and finally nature of the roots. So what type of the roots the quadratic equation has? Either they are real, imaginary or same. So these topics we have to learn to cover this chapter. In the polynomials chapter we have learnt about quadratic polynomial. So let's see here. If a polynomial is in the form ax square plus bx plus c, where a is not equals to 0, then it is called as quadratic polynomial, because here the degree of this polynomial is 2. If the degree is 2, that is called quadratic polynomial. When come to here quadratic equation. So quadratic equation, it is an equation which have the degree as 2, and the equation term denotes there's equal to. So if you make this quadratic polynomial equals to 0, then we can call it as quadratic equation. So here degree of the quadratic equation is 2. The general form of quadratic equation is ax square plus bx plus c equals to 0. In general, we can define a quadratic equation as a quadratic equation is said to be in the form of ax square plus bx plus c equals to 0, and where a is not equal to 0. So always a quadratic polynomial should be in the form of ax square plus bx plus c equals to 0. Let us see some of the examples of quadratic equation. 2x square minus x plus 4 equals to 0. So degree of this equation is 2 and it has equal to sign. So it is equation. This quadratic equation. X square minus 9x plus 5 equals 0. A quadratic equation. And here x square minus 9 equals to 0. So here x square term there. There is no x term. It means x term is 0. Now let us do some problems. Check whether the following are quadratic equations or not. So let us check whether the given is quadratic equation or not. So by looking, we cannot judge which is a quadratic equation or not. So let us simplify this. The LHS term is x plus 1 whole square. So it is in the form of world famous formula, that is a plus b whole square. Isn't it? A plus b whole square. A plus b whole square is a square plus b square plus 2ab. So apply the formula here. A square means here we get x square plus b square is 1 square. 1 square is 1 plus 2ab. 2 into x into 1, that is 2x. And here multiply 2 into x, 2x, and 2 3 ja 6. So minus 6. Transpose RHS terms to the LHS side. Then we get x square plus 1 plus 2x minus 2x plus 6 is equals to 0. So here plus 2x minus 2x will get cancelled, and the remaining terms are x square. 1 plus 6 is 7 is equals to 0. So is it in the form of quadratic equation? Yes, ax square plus bx plus c. But here x term is missing, means x term is 0. So it is a quadratic equation. Yes, it is a quadratic equation. The second example is x minus 2 into x plus 1 equals to x minus 1 into x plus 3. So multiply the LHS terms and RHS terms. X into x, x square, x into 1, that is x, minus 2 into x, minus 2x, and minus 2 into 1, that is minus 2. So when come to here x into x, x square, x into 3, it's 3x, minus 1 into x, minus x, and minus 1 into 3 is minus 3. Here we can simplify x minus 2x is minus x. Minus x minus 2 equals to x square. 3x minus 2x, it is 2x minus 3. Transpose all the RHS terms to the LHS side. Then we get x square minus x minus 2. X square is minus x square minus 2x plus 3 is equals to 0. So whenever we are transposing LHS terms to RHS or RHS to LHS terms, the signs are going to change. Don't forget this. So here x square minus x square will get cancelled. Then we get minus x, and the x term is here minus 2x minus 2. The constant term is plus 3 equals to 0. Minus x minus 2x, minus into minus plus. So by adding this we get minus 3x. Minus 2 plus 3 is plus 1 is equals to 0. So it is not in the form of quadratic equation. There is no x square term. That's why it is not a quadratic equation. Not a quadratic equation. So in this way we can simplify, we can check whether a term, whether given the question is quadratic equation or not. Now it's time for 10. Try it now. So here some problems are there based on the previous example. So check whether the given are quadratic equations or not.